This is a problem about special relativity and what happens when you assume the speed of light c is constant for all observers, and how the time elapsed between two events isn't the same for all observers. From the assumption in this thought experiment, you can see there is no one true elapsed time value. So we have a single clock on a rail car moving down a track. 2 points A and B are fixed to the track. The distance between A and B is called AB. Right there, it's indicated. Farther down past B, an observer Q is sitting on the track, and the train's coming towards her. Both A and B each have a signal lamp which will flash when the car passes over it. Okay, that's what that asterisk is. It's a flash. The rail car is moving with velocity v with respect to the track. Any flash is deemed an event, and the observer Q wants to measure the time elapsed between these two events. So that's pretty simple. Train's running down the track. It's going to pass over A, then it's going to pass over B. What's the time difference, delta t, between the two flashes? It turns out this elapsed time measurement is tricky. Maybe there is no one true value for all observers. All right, so Q, she's the organizer of this experiment. Q has two helpers, one stationed at A and one at B. These helpers don't move, they're with the track. Each helper has a stopwatch, and they have been synchronized, both starting at 0. Two stopwatches here. The plan is when helper A sees a flash, he stops his watch, and B does the same. Then, after the train passes B, A and B have a meeting and subtract their stopwatch values to calculate the elapsed time value between the flashes, A and B. Let's call this delta t that the helpers measure. Let's call that delta t. Okay. Since the helpers A, B, and Q are all stationary with respect to the track, we will call their delta t measurement the proper time measure. Quote, proper time. This is something that is used in other places. Okay. Okay, just to be sure, so they get some delta t measurement. They tell Q. All right, just to be sure, Q is actually watching this whole thing happening, and she can see the flashes happen at A and B. And she has a stopwatch. Okay. So when this happens, the train passes A and B. She actually uses her stopwatch to measure her own delta t between the A and B light flashes. Okay. And we call that delta t the delta t c, like SEE, because that's the delta t that you get by actually looking at from a distance at these light flashes. Then, to triple check the elapsed time measurement, because we really want to get the exact right value, Q hired a passenger that rides on the train car with the clock. And this passenger is just looking at the clock. And the passenger, during the experiment, when passenger sees this flash, he starts his stopwatch. And then when he sees the second flash, he stops his stopwatch. Okay, so he records a delta t. And we'll call his measurement delta t naught, delta t sub 0, to be consistent with the problem 15.10. So this whole problem is about 3 different delta t measurements, and if the velocity of light was infinite, everybody's number would be the same. But in fact, the velocity of light is a c constant. It's not infinite, so everybody gets a little bit of different answer. And Um, the simplest answer to understand is the one done by the helpers. Okay, that's the proper time measurement. The other one is not too hard to understand. That's the one that Q measures. And hers is different than the one that the helpers measure because when the light flashes, it takes some amount of time for the light to travel this distance and to reach her eyeball. And the distance is changing. So for the A flash, the light delay is one thing, and for the B flash, the light delay is a different thing. So, that's a difference there. The really bizarre thing is what P measures, and that's actually clock time. And you can see the clock hands are a little different here because of the elapsed time. And guess what? This number that P measures, it doesn't match either one of these other numbers. And that's all for now because this is too long. But thanks for watching.